Okay, so we're talking about systems of equations. What this means is that we've got we're dealing with linear equations, linear functions right now. So we've got two linear equations, and we're looking if they were to be graphed, and they will have a point of intersection. This point of intersection right here would be the solution to the systems of equation, which means that that is the point that the lines of the two graphs intersect, they cross, and there is an ordered pair there that satisfies both equations, and we're looking to find that ordered pair. And right now we're going to do this by using our by graphing them and our tables. So let's look here. We're given two linear equations. We've got 2x minus 5y equals 11. And we have a second equation, minus 3x plus 4y equals minus 13. Now, our first task is to get these equations into slope-intercept form, y equals mx plus b. And so let's tackle this one on the left. I'm going to move the x over to the other side of the equation. So now I've got minus 5y equals minus 2x plus 11. I've got to isolate the I by dividing everything by minus 5. And then that's going to give me, when I divide minus 2 by minus 5, I got 2/5 x. Negative, negative to go equals a positive. And then I'm going to divide this 11 by minus 5, which is going to give me a minus 11/5. So I've got this equation now in slope-intercept form. Let's look at the one on the right. So I'm going to add 3x to both sides. So I've got now 4y equals 3x minus 13. I've got to isolate the y. So I'm going to end up with 3/4 x minus 13 over 4. Okay, so those are my two linear equations. We're going to move here to the next slide with the calculator. Okay, so I got my calculator up. We're going to determine the solution for these two systems of equations, of the equations that we just rewrote in slope-intercept form. And really one of the first things I want to do with my calculator, I want to go check, see if my stat plot's on or off. I want it off. It is. I'm going to take a look at my Windows settings, and I got my X and Y minimum maximums at minus 10 and 10. That seems to be okay for right now. And so I'm going to go in here into Y equals, and we're going to enter our equations that we did in slope-intercept form. So for Y1, I'm going in, if you remember, I've got 2/5 x minus 11/5. And then for Y2, we solve that to where we've got 3/4 x minus 13 over 4. Okay, so let's take a look at our graph and see what it looks like. Okay, so in looking at the graph, it certainly appears that the graphs intersect right in here, where y is equal to about 3. So let's go in here and look at our table. Second graph, it's going to give me my table. And if I go right into here, I can see that when x is 3, y in the first equation is minus 1. And in the second equation, when x is 3, y is also equal to minus 1. And so that's going to tell me here that that is the point of intersection at the point 3, when x is 3, y in both cases are equal to minus 1. Now let's take a look at another example. We're going to proceed the same way. We've got a linear equation here that is 4x plus 3y equals minus 17. I've got a second linear equation that is minus 7x minus 2y equals 20. Now remember, I've got to put both of these in slope-intercept form. So over here, I'm going 3y. I'm going to subtract the 4x from both sides. 3y equals minus 4x minus 17. And now I'm going to divide the entire equation by 3 to isolate the y. So I've got minus 4/3 x minus 17 over 3. Okay, so this equation is now written in slope-intercept form. Let's go over here and tackle this one on the right. And I'm going to add 7x to both sides. It's going to result here in minus 2y equals 7x plus 20. Isolate the y by dividing everything by minus 2. So I got minus 7/2 x minus 20 over 2. Or, let's continue, minus 7/2 x minus 10. All right, so there's my two linear equations written in slope-intercept form. Let's head to the calculator. All right, so let's let's graph the second set of equations to see what our solution is for systems of equations. And let's clear out y1, let's clear out y2, let's go back up here to y1. All right, so we had two linear equations written in slope-intercept form. On one of those, I had minus 4/3 x minus 17 over 3. And for my second equation, I had minus 7/2 x, 7 over 2x, minus 10. All right, let's take a look at our graph here, see what we got. And so it would look like, certainly we've got a point of intersection here. Let's go take a look, see here what in our graph, our table. I'm going second graph to get to my table. I'm going to be looking for where minus 2 is. X is equal to minus 2. And there we are. When x is minus 2, our first equation, the y value for the first equation gives us minus 3. And also in our second equation, when x is minus 2, y is also equal to minus 3. So our solution set is parentheses minus 2, comma, minus 3.